Faster than the very fabric of space-time itself, it possesses the ability to remain aware of it. Consequently, it will gradually dismantle this concept, filling me with a growing sense of discomfort. At this very moment, the night sky above is undergoing rapid transformation, and in the coming decades, possibly even sooner, it could become entirely unrecognizable. Leading experts, including Neil deGrasse Tyson, have sounded the alarm, acknowledging the inevitable changes brought about by the shifting position of Polaris. The changes behind this phenomenon are surprisingly unexpected. Polaris, widely known as the North Star, has been a dependable feature in the sky for millennia, serving as an essential point of reference for astronomers, navigators, and stargazers alike. However, this could soon be altered, changing the way we perceive the heavens and the manner in which we explore the universe. Let's delve into the implications of this transition. For centuries, Polaris has been a guiding beacon for sailors and astronomers, remaining steadfast in the sky. This constant presence has been crucial for navigation, but this stability may soon be disturbed. A paper released by the prestigious Royal Astronomical Society in September 2023 raised alarms regarding the future of this celestial marker. Polaris is entering a turbulent phase, one where it may explode and disappear from view forever, radically altering the sky we know. Before considering the potential outcomes of this event, let's take a closer look at the characteristics of the star itself. Polaris stands out due to its position near the celestial North Pole. Located directly above Earth's northernmost point, it appears almost motionless in the sky. It is part of the Ursa Minor constellation, which is often referred to as the Little Dipper. Polaris emits a moderate level of brightness and is categorized as a yellow-white supergiant star. It is significantly larger and brighter than our Sun. However, Polaris is not just a single star. It is part of a complex triple star system, composed of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational interactions between these stars influence their orbits and behaviors, and any disruptions in these interactions could cause shifts in their brightness or pulsation patterns. Despite this, the exact nature of these forces is not yet fully understood. Polaris is located approximately 323 light-years away from Earth, meaning that the light we observe today began its journey a long time ago. If Polaris were to explode, the effects would not be visible to us for over 300 years. It is even possible that Polaris has already exploded, but we have yet to observe the results. Throughout history, the North Star has held profound cultural, navigational, and symbolic significance. Its unwavering position in the sky has made it an invaluable guide for ancient sailors navigating across vast seas and lands. Symbolically, Polaris has represented constancy and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has served as a crucial reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided critical insights into the properties of stars and the behavior of variable stars. This trait has also been essential in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable pattern. Its behavior has been relatively easy to forecast. However, recently, Polaris has begun to show signs of deviating from its usual behavior. This irregularity in its pulsation cycle has caught the attention of astronomers, prompting further investigation into the cause of these unexpected changes. Rather than following its typical rhythm, Polaris has begun to exhibit erratic dimming, raising concerns that the star may be nearing the end of its life cycle. This behavior aligns with patterns seen in stars that are approaching their final stages. The gradual increase in Polaris's pulsation period, which was once steady, has been traced back to interactions within its star system. Over the past year, there has been an annual increase of approximately 4.5 seconds in the pulsation period. While this might seem like a small change, it holds considerable implications. Some astronomers propose that the gravitational forces between the stars in the Polaris system could be driving these changes, directly affecting its atmospheric conditions and pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between Polaris's behavior and that of Betelgeuse, a prominent star in the Orion constellation, are striking. Both stars have displayed complex variations in brightness, which has led to concerns that they might be nearing a catastrophic explosion. Stars nearing the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it goes through several stages, including the red giant phase, and ultimately ends in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, which is typical for giant stars nearing the end of their life. These irregularities align with patterns seen in other stars nearing their final stages. However, solid evidence of an impending supernova remains uncertain, and astronomers continue to monitor these anomalies to better understand the fate of Polaris. If Polaris were to undergo a supernova explosion, it would be an extraordinary event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key constellations, like the Big Dipper or Ursa Major, in which Polaris plays a critical role. Fortunately, Earth would likely remain safe, regardless of whether Polaris explodes, due to its immense distance from us. While the explosion of Polaris might not be as visually stunning as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. Now let's turn our attention to what will happen to Polaris itself. What is its future after a potential supernova explosion? It's crucial to understand that although massive stars generally end their lives in a supernova, this is unlikely for Polaris. When a large star goes through a supernova, its core collapses, triggering a violent shock wave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not result in a supernova. Instead, it will mark a quieter conclusion as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium mass star that has depleted its nuclear fuel. Despite its small size, roughly that of Earth, it will still contain the mass of the Sun. Once this transformation occurs, we will no longer observe Polaris as we know it. By comparing the potential explosion of Polaris to actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate fates. For example, supernova events like SN 1987A, SN 2011FA, and SN204J have provided crucial data that help us understand what might happen to Polaris in the future. SN 1354, for instance, resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, offering astronomers a rich field of study. Furthermore, SN 1987A, observed in the Large Magellanic Cloud, provided essential insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries help us understand the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula occurs when the material ejected during a supernova explosion interacts with surrounding interstellar gas and dust. This process enriches the gas with heavier elements, contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the production and speed of ejected material between a potential Polaris explosion and other observed supernova events. By analyzing light curves, spectra, and remnants from these events, they can make predictions about the potential explosion of Polaris. This research will help determine whether Polaris's explosion could lead to nebula formation or impact stellar distributions in notable ways. Another critical area of study involves the pulsational variability of stars approaching the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind star explosions. The very creation and pulsations in stars nearing the end of their life may indicate internal instability or an imminent catastrophic event, providing valuable clues about the processes that lead to supernova explosions. Despite detailed observations and ongoing research, space experts remain puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is vital for advancing our knowledge of stellar evolution. Investigating the factors responsible for Polaris's erratic pulsation requires collaboration across multiple scientific disciplines, along with the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need recalibration, which would affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers. This emphasizes the significance of such an event. The mysterious behavior of Polaris highlights the pressing need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The disappearance of Polaris would have significant implications for various fields of study and cultural practices. One of the major consequences would be the need to recalibrate astronomical tools and methods. Since Polaris has long been a reliable reference point for measuring distances in the cosmos, its vanishing would disrupt current models of the universe. Astronomers have relied on the predictable behavior of the star for centuries to help them map out the cosmos. Without it, other methods of measurement would need to be developed, which could take years of study and adjustment. Moreover, Polaris has always played a crucial role in navigation, especially for sailors and travelers. Its constant position in the sky has helped guide explorers through vast oceans and across unfamiliar lands. If Polaris were to vanish, the disappearance would create challenges for modern navigation systems that still rely on celestial bodies. For orientation, this could be especially problematic in remote areas where electronic navigation aids might not be as effective or accessible. In addition to practical concerns, the cultural significance of Polaris cannot be overlooked. For many ancient civilizations, the North Star symbolized constancy and direction, offering a sense of stability in an otherwise chaotic world. Its disappearance would likely have deep emotional and psychological effects on various communities, particularly those who have long associated the star with guidance and hope. Even today, many cultures continue to see Polaris as a symbol of unchanging steadiness in the face of life's uncertainties. The potential fading of Polaris also emphasizes the dynamic and ever-changing nature of the universe. Stars like Polaris go through various stages throughout their lifetimes, and their eventual death is just a part of the natural cosmic cycle. While the thought of losing such a prominent and dependable star might seem unsettling, it also serves as a reminder of the vast and complex processes occurring in the universe beyond our comprehension. Just as new stars are born and old ones die, the heavens above us are constantly shifting and evolving as we continue to study the stars and their behavior. The changes in Polaris's pulsation patterns will likely provide astronomers with even more information about the life cycle of stars and the forces that govern their existence. This knowledge could ultimately help scientists understand the broader processes behind the formation, evolution, and death of stars. By investigating how stars like Polaris behave as they near the end of their lives, we can gain insights into the mystery of stellar evolution and the ways in which the universe itself is constantly transforming. Despite the uncertainty surrounding the fate of Polaris, one thing is clear: it has been an invaluable resource for astronomers, navigators, and cultural traditions for centuries. Whether it ultimately transforms into a white dwarf or goes through some other unexpected phase, its eventual disappearance will undoubtedly mark the end of an era in our understanding of the cosmos. However, as we've seen with other celestial events, new stars and new discoveries will continue to emerge, offering humanity fresh insights into the nature of the universe. While the changes happening with Polaris may be alarming, they also provide a unique opportunity for scientists and researchers to explore the fundamental principles of stellar life cycles and the cosmic forces that shape them. The future of Polaris is still uncertain, but the journey to understand its eventual fate is an exciting one, offering potential breakthroughs in our understanding of the universe and the forces that govern it. As we continue to monitor Polaris and its shifting behavior, astronomers are grappling with how this star's transformation might affect our broader understanding of the universe. The potential loss of a steady celestial landmark forces us to confront how fragile our current models of stellar dynamics and cosmic measurements are. Since Polaris has served as a key point for calibrating telescopic instruments, the eventual disappearance or alteration of the star could necessitate the development of new techniques and methods for measuring distances in space. In addition, Polaris's gradual departure from its consistent role could push the scientific community to explore more deeply the mechanisms behind the behavior of variable stars. Understanding the variations seen in stars like Polaris and the conditions that precede their end stages could revolutionize how we perceive the life cycle of stars in general. These studies could extend beyond the Polaris system, influencing Our research into other variable stars and their potential to evolve into phenomena like supernovae, neutron stars, or white dwarfs. Another fascinating aspect of this situation is the ripple effect it could have on how we engage with the universe. For instance, Polaris has been the focal point for countless myths and cultural stories across generations. If the star were to fade from view or dramatically change, it would alter the way various communities interact with the night sky. Those who once viewed it as a symbol of hope and constancy might feel an emotional and spiritual void. This eventual shift in the position of the North Star could also inspire further exploration into the complex relationship between gravity, stellar motion, and the structure of the universe. As we venture beyond our current understanding, the disappearance of Polaris may prompt more targeted research into the intricate dance between celestial bodies.